Yeah. So again, welcome back to the next session. Today we'll be revisiting arrays. Okay. So since the base everything revolves around the arrays, I wanted to have another session of arrays with you. Okay. So in C, normally when we say int a of 10, right? We call a, or we say a is the name of the array and 10 is the size of the array. Okay. We call a is the name and 10 as the size. So immediately when an array a of 10 is declared, what happens? Your compiler ensures that you have 10 memory locations, okay, that are adjacent to each other, right? When you say an array, they are locations that are adjacent to each other. An arrays can have similar data type. It cannot have different data type. If you say int a of 10 and say the size of integer is 2, immediately 20 bytes is allotted for a, okay. And a is an array with indices starting from 0 to n minus 1, where n is the size of the array, okay. So here in this case n is 10 means 0 to n minus 1. So I say the 0 to 9 are called the indices, and the elements are the values of that. For example, a of 4 is 72, a of 8 is 99, okay, a of 9 is 18. If I try to access a of 10, it will say index out of bounds, okay. So an array is a very simple data structure which is having an index and which has its values, and they are direct access, okay. You can directly access them with their index. For example, you say a of 2, it is 27, okay. So normally we visualize array as this. Say for example, I have something called as an array int a of 6, and the values of are 10, 20, 30, 40, 50, 60, okay. The indexes are shown here 0 to 5. Normally in the compiler, what it does is in the system memory, it is as the location 9000. If 9000 is the starting address of a, so a of 0 will be at 9000, a of 1 will be at 9002, a of 2 will be at 9004, a of 3 will be at 9006, a of 4 will be at 9008, and a of 5 will be at 9010. So if you see 6 into 2, 12 bytes of memory are allotted, okay. So direct access is possible. For example, if you say a of 2, immediately what happens? It calculates the base address is 9000 plus that for 0 1 2, so 6, so it goes there, okay. So a of 2 means 2 into 2 4, so 9000, obviously it is going to be at 9004, okay. So it is easy to calculate the address of any location in an array, and therefore you are able to have direct access, okay. So we talked about the operations of an array, okay. And we said the various operations of array are: you can traverse an array. What do you mean by traversing an array? Reading the entire elements that are in an array, okay. Say for example, let me check whether I have an example of array traversal. Yeah, a simple array, yes. So what happens? You have declared a of 10, enter the number of elements in the array. So maybe I'll say 5 elements I'm going to enter. Immediately I'll say enter the elements of array. For I equal to 0, I less than 5, I can scan of all the 5 elements, and I can print the same. For I equal to 0, I less than 5, print this, okay. So this is called as traversal, where you're able to read elements and traverse this. So just let us run and see. I think the previous program is not running, or what? Yeah. So we hadn't exited on the press. So let me run this. This is a basic program. Okay, enter the elements of array. So I said I'll enter 5 elements, maybe 9, 19, 29, 39, 49. Okay, so obviously the array elements are 9, 19, 29, 39, and 49. So this feature is called as traversal. You are just traversing an array. Okay, then let us revisit the insert option. You remember the insert option that we saw in the first class of how we did it, okay. So normally when you declare a of 6, immediately you have 0 to 5 indexes, okay. 0 1 2 3 4 5, where you have 6 locations. And for example, if you say the number of elements you're going to add is 4, okay. So a of 0 to, sorry, number of elements to be added is 5, okay. So only then it will be a of 0 to a of 4. So you have 0 1 2 3 4 with values 9 29 39 49 and 59. Now my question is, I want to insert at position 2. Okay, my position 2 means it is 1, right? I mean A of 1. You got my point? Because this is my first position, this is my second position, this is my third position. So if I want to insert at position 2, that means at A of 1, if I simply put A of 1 is equal to that value 19, this 29 value is lost. So the resultant will become 9, 19, 39, 49, 59. But that is not insertion. This is called as updation. I want to insert. So when I want to insert, what happens? All the values all the values that have the index from 1 to 4 have to be shifted one step right. Okay, remember, now there is a logic for you to think here. If I shift 1 to 2, what happens? 29 comes here, but this 39 value is lost, right? So you will never be able to get that value. So when you talk about insertion, you should go that n minus 1th location and move that first. Okay, that is what I've pictorially done here. First you move a of I plus 1 is equal to a of I, right? Again, this a of I plus 1 is equal to a of I. Again, this a of I plus 1 is equal to a of I. So you can change your value of I from n minus 1 to less than, greater than or equal to position minus 1. Okay, right? Only then there is a hole here, and then you can say a of position minus 1 is equal to val. I repeat, right? You have an array A of 6, so it runs from 0 to 5. Okay, you're going to add 5 elements, right? You have added it 9, 29, 39, 49, 59. Now I want to insert at position 2 with the value 19. Okay, so for me to insert at position 2, there should be a hole for me to insert. Since there is a data, the data shouldn't get lost. So I should move the data to the next A of I plus 1. But if I start from position minus 1, the next it will get lost again 29, 29. So everywhere it will become 29. So my practice should be, I should start from n minus 1 and go to the next location, right? So this 59 is moved to the next location, 49 is moved to the next location, 39 is moved to the next location, 29 is moved to the next location, and therefore a hole comes and I can insert the value. So what is the logic? I ranges from n minus 1 to equal to position minus 1. So then a of I plus 1 is equal to a of I. So first time 59 is copied here, 49 is copied here, 39 is copied here, 29 is copied here, and there is a hole, right? So that's what 1, 2, 3, 4 times it is moved, and then I say a of position minus 1 is equal to var. Okay, so let us look at the code for the same array insertion. Okay, look at the code. It is very simple. I have a of 10, enter the number of elements in the array. So I'm going to say again 5 elements. I'm going to enter all those elements for I equal to 0, I less than n. I'm going to enter the element. Okay, so I have read it. Now enter the position to be inserted. I'll put the position as 2 and the value as 19. Okay, then what I do, this is my code. For I is equal to n minus 1, I greater than equal to position minus 1, I minus minus. I talked about that a of I plus 1 is equal to a of I. And next it says a of position minus 1 is equal to val. Okay, so then you can print all this. For I equal to 0, you can print it. Okay, you're printing those elements. And remember, since you are inserting it, you have to increment your n value, because previously you would have had only 5 values. Now you'll have 6 values. So only if you increment that 6, you'll be able to display that particular this one. Okay, I think there is another, the previous program hasn't been extended. Yes. So now let me run this. The same example we'll enter 5 elements. So the elements I entered was 9, 29, 39, 49, 59. Okay, enter the position we inserted 2. I'm going to enter the element 19. Okay, see 9, 19, 29, 39, 49, 59. All the elements are safe. Okay, so the next element that I wanted to discuss was the deletion of an element. Okay, let us go to the deletion. Yeah, so again the same example. I'm always having the same example so that it is easy for you to recollect the examples. So a of 6, so 0 to 5. Okay, number of elements again you have added is 5. So 9, 19, 29, 39, 49 are there. So now I want to delete the element at position 2. Okay, So you can say straight away I'll delete it, sir, to 0, right? But it will be then 9, 0, 29, 39, 49. That is not the order of elements. It should be 9, 29, 39, 49. So here what you do, you start from position -1 to less than n minus 1. So when you start from position -1, a of I is equal to I plus 1. So 29 will come here, 39 will come here, 49 will go there. Okay. So we'll see the code blocks program for it. Array deletion. Okay. The same concept, ARR of 10, number of elements is ampersand 10. So for I equal to 0, I less than n, you're going to read all those elements. Okay. Then you're saying enter the position to be deleted. And as per our logic, we start from position -1 and move on to less than n minus 1. And we say a of I is equal to a of I plus 1. Okay. Fine. Right. So when we run this, yeah, we'll run this. We'll have a problem here. Enter the elements 5. Enter the first element 9, 19, 29, 39, 49. Okay, position related 2. And I got it as 9, 29, 39, 49, 49. Why has that 49 come twice? Can you tell me? Yeah, somebody can share your experience. Why has that 49 come twice? Remember, 49 is here also. Okay. Normally this is shifted here. So 49 is here, but I have not decremented n here. I have not decremented n here. If you remember in the previous code, I would have put n plus plus. Here it should be n minus minus. You can save it. You can build it. Okay, it is built. And now if you run it, yeah, and I'm on 5, 9, 19, 29, 39, 49. Okay. See now, it's correct, right? So I hope you have understood that array concept that I wanted you to look into it. Okay, so we would have seen inserting, deleting, traversing, updating. Okay.